So today, there's a couple of things that I want to get into, and one of them is it's just going to be an introduction, and it's because it's a concept that's very difficult for a lot of beginning programmers, and it's the notion of identity versus equality. And the reason it's difficult is, well, it's sort of a foreign notion. It's not something we come up against in, let's say, real life every day. And it's also tied in with deeper programming, not paradigms, but objects, and those objects are pointers, so things which cause, again, a lot of grief. So let's say A equals 4 and B equals 4. What if I say A equals B? So are A and B equal? That's true. Okay. What if I say A is equal to range, A is equal to range 5, that's A, and B is equal to 0, 1, 2, 3, 4. Is A equal to B? There's A, there's B, they're equal. And if I say S is Pat Morin and T is Pat plus Morin, there's S, there's T. Is S equal to T? Yes. Okay, this doesn't seem difficult to understand. Well, in Python and in many other languages, there's another way to compare things, and that's to ask if they're identical. So here's our x and y again. And in Python, there's this keyword called is. So I can ask, x is y. Are these two things identical? True. Okay. A and B. A and B, are they identical? False. Strange, right? So x equals 4, y equals 2 plus 2. We ask, are those identical? It tells us it's true. A, remember, was something we got by building a range. B was something we got actually by copying and pasting A, so it's exactly the same elements in there. And yet it says that they're not identical. And remember our two strings, S and T. Are those identical? No. What's going on here? So it said that these integers 4 and 4 were identical, but it says that A and B are not identical. So let's see. There's A, there's B. So what does it mean? What do you think it means that they're identical? Yeah. Yeah, that's that's exactly the right definition, but most people won't know what that means. To be identical means that they're really the same thing. They're actually the same object in the same location in memory. So is there a way to test if A and B are the same object at the same location in memory? So we think that they're not, because A is B seems to suggest that A and B are actually two different things. So how could we test this hypothesis? Yep. Yeah, let's change one of them and see if the other one changes too. So I could say a at 1 is equal to blah. There's a, there's b. So these are different things. A and b are actually, the reason it's telling us they're not identical is because they're really not. They're two different arrays that just happen to have stored the exact same elements, but if I change a, that doesn't affect b. Yeah?
So when you say x is 4 and y is 2 plus 2, if you go x plus equals 1 and then you print y, it'll still be 4.
So plus equals, remember all that is a shorthand for x equals x plus 1. So that's reassigning a new value to x. So it's not quite the same thing as saying, you know, x dot append, or it's not changing 4. It's just assigning a totally new thing to x. So for example, well, well, we won't worry about that for now. So is this distinction really important? So let's test this thing. Let's say a equals b. There's a, there's b. Now what if I ask if they're the same, if they're identical? True. So now it says true, they are identical. Let's test to see if they really are identical. Let's say a at 3 is equal to oh, wrong quote. That's a, and that's b. So indeed, changing this element in a changes the element in b. So this is confusing, which is why we're covering it early, and it's going to come back again, because this kind of mistake will come back and bite you many, many times as a programmer, and it will never stop. But at least if you understand this well, you'll recognize it as soon as it happens and know what you need to do to fix it. So the best way to understand this thing is with these box diagrams. So we had this code that said a is equal to range 5. So what does range 5 do? Range 5 creates an array that contains 0, 1, 2, 3, and 4. And when we assign that to A contains whatever you want to call it, a reference or a pointer or something that refers to that array that we've created. Okay. And then after that we said B is equal to 0, 1, 2, 3, 4. So this is us also creating an array. 1, 2, 3, 4. And then assigning that to B, so B refers to it. So then when we do something like A at 1 is equal to what? Then that says, well, let's find the first location in A. Oh, that's over here. And let's set that to what? So we cross that out and we put in what. That's why it doesn't affect B, because it's actually a different location in memory. Later, we say A equals B. So what does that do? That takes this little box here that is the variable A and says, look, don't refer to whatever you used to refer to. Stop being whatever you are currently and become the same thing as B. Or if you like, copy the value that's stored in B right into that location. And the value that's stored in B is a reference to this array, so now A is also a reference to that array. And now when we start messing with A, with something like A at 3 equals how, then that changes A at 3, how, which also happens to be the same thing that's B at 3. What's that?
Isn't that A and 4?
Yes, yeah. That's no, that's right. The range of 5 is yeah, no, that's right. A at 3 is 3. Okay. So this is a really important thing and a huge source of errors, right? It's really important to know whether something that you change is actually going to affect everything else or it's only going to affect it for you. And so this is something we need to look out for. So there's this equality operator, which is actually the one that's more confusing. So when we say A equals B, for some reason it returns true even when they're two different arrays that happen to contain all the same elements. But when we say A is B, it's actually completely obvious now why this returns true or false. It either A and B refer to exactly the same thing in memory, or they don't. So if they refer to the same thing, then A is B, and if they don't, if they refer to different things, then A is not B. So why is it that when we say X equals 4 and Y equals 2 plus 2, and then we say X is Y, the answer is true? So in this box picture, what happens when we set X equal to 4? Yeah. Yeah. So when we set X equal to 4, the integer 4 goes right in the box. The box doesn't contain a reference to some integer somewhere else. The integer 4 just goes right inside that box. When we take Y equals 2 plus 2, well, we calculate 2 plus 2. The answer is the integer 4, and that fits inside this box, this variable Y. Now, actually, we see something even more clear. X is Y is just asking the question, is the value that's in the box for X, is that the same value that's in the box for Y? In this case, they both contain 4, so X is Y. In this case up here, if A and B both refer to the same array, don't think of it as referring to the same array. That's not relevant. What matters is the value that's in this box for A is exactly the same as the value that's in the box for B. So this is really just a test for equality of what's stored in the variable, not what it refers to. It could be a pointer, it could be an integer, or whatever. It just checks if those two things are equal. Yep.
That's true. It doesn't matter what size.
Yeah. So here's the thing. This means that to understand is and equal, you have to know what objects, or what things in your language are small enough to fit in one of these boxes. They're usually called primitive types, and what things are too big to fit inside these boxes. So for example, arrays, well, they're arbitrarily large, right? They can grow arbitrarily large, so we don't actually, these boxes just have a fixed size, so we can't store an arbitrary list of numbers inside one of these boxes. Instead, we store a reference to that list. Integers, on the other hand, at least the small ones, they fit in these boxes. But we've seen something in Python that we're not sure yet whether or not they fit in these boxes. So anybody remember the strange integers we've seen? Yeah. Yeah. So W is 2 to the 200, let's say. So that's W. And remember, when we're looking at the programmer's view of W, not when we print it, but when we just inspect its value, it gives us this little L at the end, saying that this is a long integer. It's somehow different than just an integer. So let's try U is equal to 2 to the 100, 2 to the 100 times 2 to the 100. So W is equal to U. Same values, right? Do you think they're identical? No. So, same reason. The picture looks like this. U is just a variable. It has just this constant size box associated with it. W as well. Now, we do this calculation, compute 2 to the 200, and Python is smart about doing these kinds of calculations. It realizes right away that this isn't going to fit inside a regular integer. It needs to make a long integer, which has its own representation. It's actually a sequence of integers. And so it goes and makes this long integer with all of these L that's the result of computing 2 to the 200, and when we assign it to U, U just contains a reference to that. Similarly, we did a calculation for W. Python realized it needed to go beyond the limits of these regular native integers or primitive integers and use long ones, and so it did that. And that's why U and W are not identical. On the other hand, if I say W equals U, then that picture changes to this picture. Cross this out, and W now points to the same thing. Or more precisely, the value here that's stored in U, which is a reference to this array, is copied into W. And so they're identical. So if I could change W, then that would also change U. Okay. Is that clear right now?
I have a question.
Yeah.
If A equals range 5 and B equals array 0, 1, 2, 3, 4, and X equals A1 and Y equals B1 and X is Y is true.
Yep. So you say we have A and B. A is B, that's false. So that's back to this picture from the previous page where A points to this and B points to this. And now you say X equals A at 1, Y equals B at 1, and you're asking X is Y. So what do people think the truth is there? Yeah. Yeah. Well, let's finish this one and then. True? True. Why?
Because it's disregarding the array and just assigning itself the integer within that, which is small enough that I can hold it.
Yeah. So again, what's stored in A at 1 is just a regular small integer. And so when you assign that to a variable that's small enough, it just fits inside the box for that variable. And so the picture after doing that is the same. Well, it's actually this picture here. The 4 goes right in the box for x, or whatever it was, not a 4, a 1 in this case. Goes right in the box for x, and a 1 goes right in the box for y. They came from different locations, but they're the same thing. They go there. So this is really just a comparison for equality, but not, well, it's a comparison for equality on what's actually in those boxes for those variables, not what they refer to. Yeah. Yep.
For the next one you did with U and W, if you calculated U the same way you calculated W, like you do both where W is equal to 2 to the power of 200,
Yep.
U is equal to the power of 200, that would still create two separate blocks, right?
Yeah. So that still creates two different things. And that's just because, well, when Python evaluates this expression, it realizes it needs to make this long integer, so it does. When it evaluates this expression, it realizes it needs to make a long integer, so it makes another one. Yeah.
So you know in C++ we got the ampersand sign and the star sign to deal with references and pointers.
Yeah.
Is there such a thing in Python, or we just have to deal with how it assigns values and references?
Well, in Python, almost everything is a reference, except for a handful of simple types. Int, float. Those things are not references. They fit in a box. I think that's true. Let's see. Oh, no. Even floats are not. Even floats don't fit in a box. So actually, int is this thing that fits, and then there's references to everything else. Booleans may fit also. Yeah. Yep.
Suppose you have two different arrays, A and B,
Mm-hmm.
and you want to make A equal to B, but be its own array.
Yep.
How would you do that?
So if I want A to be equal to B, so to be a different array that contains the same elements as B, shortest way to do that is like this. The other way around. B is equal to A, like that. So remember this is the slicing operator that takes a slice out of an array, so some of the elements in an array. So it actually makes a new array with those elements in it. In this case, the range says go from the beginning to the end. So everything in A.
String is also work with A and B, but if you have a character like a star in that string, and you compare those, it comes out as false, but is it still a string?
How do you mean?
You do A equals star.
Like that?
Yeah.
Yeah.
And then you do B equals star.
Yeah.
So it's false.
So S equals B is true, and S is B. S equals B is true, S is B is also true. So this is interesting. Is this a string? False. So a single character string actually is just a single character and gets stored a different way. And that thing is small enough to fit inside one of these boxes.
Is it just stored as it's like ASCII numbers?
Yep. Or its Unicode value. So that sort of makes sense. Because if you look at, for example, right, we were able to look at individual characters in string, indexing them. So that gives us this thing that has the same notation as a string, but it only has one element in it. Much in the same way that if we take an array and we ask, what is A at 5? Well, that's not an array. That's just whatever's stored at position 5. So it can be a different thing than an array. It can be an integer or a string or a character or whatever. So, strings of length 1 are characters. And characters seem to be able to fit in a box. Now, the good news about this is mostly, for many things, it doesn't matter. So, for example, for these extra long integers, it doesn't matter whether they're equal or identical, or it doesn't matter if two extra long integers are identical or not. And the reason is, and this is true for strings as well, that they're immutable. So you can't change a string. You have a string, you can't change its individual characters, right? We've tried that before. If I try and say s at 4 is equal to x, it says no, it doesn't support item assignment. Similarly, I don't even know what you would do. What you could do to an integer to change the integer itself, right? You can use it in an expression, but that just gives you a different integer. So that gives you this new thing. And as long as you can't change something, it doesn't matter whether two things are identical or not, right? So it makes no difference whether u and w refer to the same thing or whether they refer to different things, because the only time it matters is if I go and change this thing. But these kinds of integers, you can't change them. The same thing with strings. But it matters a ton for things like lists, because indeed you can change the individual elements of lists, and if A and B are identical, well, you're changing both of them, or you're only changing one, but they refer to the same thing. So, so that matters a lot. Okay. So any questions about that? This is a really deep lesson. Really important. Yeah.
When would you use that in programming?
Well, here's an example. And here's an example where things really... oh, when would you use is over equal equals? Well, often you would use it for exactly, for determining exactly these conditions, whether if I change this, am I going to change the other thing as well? So, for example, you might do something like, well, you might write a piece of code that looks something like this. And say, if A is B, then fix that. I don't want actually these two things to point to the same location, so I would do something like then say A is equal to B. Make A into a copy of B. Right. That's what this does. If A and B are the same, then make A into a copy of B, and then here you go on and work on A and B independently without overwriting them, for example. Okay. Yep. Lists it would work on. it's like I said, it would be irrelevant if A and B are strings because you can't change them anyway. It'd be irrelevant if A and B are integers or floats because those don't support changing. But actually, anytime A and B are objects that support some kind of changes, this matters a lot. Okay. All right. So the second part of the lecture today is supposed to be about objects, because this is something we need to understand. This equality versus identity is something we need to understand for objects. So anybody heard of objects as a programming thing? Object-oriented programming? So what are some of the keywords you hear about when you talk about objects? Yeah? Transmutation, yeah, that's a big one. Polymorphism, classes. So you hear about classes and you hear about instances, so the difference between classes and instances. So object-oriented programming is a way of modeling data in your program in a way that seems to make sense in something like the real world. So for example, let's say I have a program which is supposed to keep track of people, right? Maybe it keeps track of the students who are enrolled in this class, or maybe it keeps track of driver's license, people's driver's license records, or whatever. So that means there's this whole bunch of, we want to store all of these people, and any one of them is a person. So I'm a person, you're a person, the people out there are, each one is a person. So there's this whole class of things that are persons. That's us. Each one of us is a person. We're an instance of person. So you can define a class called person. This class is, I should save it, what's 27th? So what do persons have? So persons have age, they have lots of things. What's that? Lungs. Yeah, they have lungs. Names. More specifically, they have first and last names. And they have BMIs, they have height, they have weight, they have children. So this is one of the interesting things about object-oriented programming is, well, you say, oh, I want to create this kind of class of objects called person. What do persons have? And then you suddenly come up with an infinite list of attributes. So that's actually one of the pitfalls of object-oriented programming, is you really have to understand what the scope of your modeling is supposed to be, right? If I was doing an application in which I was doing BMIs, maybe I would like the people to have height, weight, and BMIs, so some medical application. If I'm doing a driver's license application, maybe they have things like a date of birth and a driver's license number and first and last name. So there's a whole, it depends on the application what attributes you want them to have, but one of those is that, let's say, a real simple person has a first name and a last name. So let's quickly define a simple person. Okay, so really quick, when you define a class like this, so this is the person class, it needs to have a way to create instances of this class. So the way you create an instance of this class is by specifying the first name and a last name. And everything in a class, every method in a class takes this extra argument called self. We'll see how that works in a second. So let's say I have a person. It's in this method, it's referred to as self, and I want to just print it. So it would be something like print chess, chess. So if we look at this init method, we set self.firstName to be whatever this argument fn was. We set self.lastName to be whatever this argument ln was. And then when we want to print a person, we print their first name and their last name. So let's see if that works. So I want to create a person, first name Pat, last name Moran. So what's me? Tells me it's a person object. And if I say me.printIt, it prints Pat Moran. Okay. So calling this thing that looks like a function, person, is actually calling this method here and setting the first name and last name using this syntax. So now that I have a person, the name is me, I can call this other method, printIt, that actually prints the first name and last name. Yep.
What's self referring to? Like object?
Self refers to the this instance of person that you're working on now. So I can also create another person. And if I say you.printIt, then I get that other person's first and last name. Me equals you. False. Me is you. If me is you, then me equals you. What if I say him equals you? And now him equals you. True. Him is you. True. Okay. So dwell on that for a little bit, and we'll pick it up again next class.
Oh, I have just one quick question for you that doesn't really relate to this.
Yep.
Like, you make a variable that can be accessed by multiple methods without having, like, it be specifically passed